As we're working through Nonlinear Systems Study Island, just a couple of quick things to help you through writing some of the equations to help find the solution to the system. So our first example is the shorter leg of a right triangle has a measure of x plus 5. The longer leg is 1 less than 3 times the length of the shorter leg. The hypotenuse is 13 more than 2 times the shorter leg. The area of the triangle A is 2.5 times the magnitude of the perimeter. So we have to create a system of equations to model the situation above. Determine if there are any solutions, and if possible, whether or not they are viable, which means are they a possible solution given the situation. So let's start by writing some of the equations from the information we're given in the question. So I'm going to start by drawing my right triangle. And let's take a look at the information that they provide us. So the shorter leg has a measure of x plus 5. Then it tells us that the longer leg is 1 less than 3 times the length of the shorter leg. So if it's 3 times the length of the shorter leg, then that means, let me slide this over for us. It's going to be 3 times our shorter leg is x plus 5, and it's 1 less than that. So there's the length of our longer leg. Now we can simplify that by using our distributive property and then combining like terms. So that'll give us 3x plus 14. So that's the length of our longer leg. Now let's take a look at the hypotenuse, which says it is 13 more than 2 times the length of the shorter leg. So it's going to be 2 times the length of the shorter leg. So that would be 2 times x plus 5. And it is 13 more than that. So again, now I need to work to simplify that. Using our distributive property, we're going to get 2x plus 10 plus the 13. So that will simplify to 2x plus 23. Given our 3 side lengths, the next thing we need to work towards is finding the area of a triangle. So quick reminder that the area of a triangle is equal to 1/2 base times height. So as I take a look, here is my base because it's perpendicular and 90 degrees to the height. So finding the area is now going to be 1/2 base times height. So now we're going to need to work to simplify that equation. So let's start with using our distributive property, aka the FOIL method in this case. So be 1/2 times x times 3x is 3x squared. Outside, x times 14 is 14x. Inside, 15x. Last, 5 times 14, 70. Combining our like terms, so I get 3x squared plus 29x plus 70. To take half of that and distribute now my 1/2, that's going to leave us with 3/2 x squared plus 29/2 x plus 35. So we now have the area. Now that we have the area, the question says that that's 2.5 times the magnitude of the perimeter. So now we need to go back and find the perimeter. So as we go to find the perimeter, we do know that the perimeter is all of the sides added together of a triangle. So as I go to take the perimeter, it means I'm going to take my short side, x plus 5, plus my longer side, 3x plus 14, plus my hypotenuse, which was 2x plus 23. Combining our like terms together, x plus 3x plus 2x, it's going to give us 6x, positive 5, positive 14, and positive 23 will give us 42. Now it does say that the area is 2.5 times the magnitude of the perimeter. So in order to find that, change up our color here. That means the area is 2.5 times the perimeter. So that means it would be 2.5 times our 6x plus 42. As we go ahead and distribute that out, we're going to get that that equals 15x plus 105. Last but not least, it told us that the area of the triangle is, which we know represents equals, 2.5 times the magnitude of the triangle. So now we have our systems of equations, with our two equations being 3/2 x squared plus 29 over 2x plus 35 and 15x plus 105. Given this systems of equations, we can now solve for viable solutions. You've got it from here. Solve those viable solutions and think about, when we're talking perimeter and area, what can side lengths be and what can side lengths not be. All right, let's take a look at this second example. So we've got Oliver is constructing a new office building. He would like for the length of the main conference room in the building to be 3 feet longer than it is wide. The building manager plans to put a conference table in the room. The value of the perimeter of the table is equal to the value of its area. After putting the table in the conference room, the manager calculates that there will be 179 square feet of walking area left in the room. He also finds that the perimeter of the room is 2 times greater than the perimeter of the tabletop. So lots of key information there. So we want to use x to represent the width of the conference room and y to represent the area of the tabletop. In order to write this systems of equations, let's start putting together the pieces that we found through the introduction. So first of all, we have to talk about the area of the room, and we know that the perimeter of the room is 2 times greater than the perimeter of the tabletop, and that the perimeter of the tabletop is equal to the value of its area, and that there's 179 square feet of walking area left in the room. So to find the area of the room, since x is the width, that would be x times, we know that it is 3 more for the length of the room compared to the width, because it's 3 feet longer than its width, minus the tabletop. So we have to take away that area of the tabletop, and we know when we do that, we get 179 square feet. As we simplify this, we get 179 equals x squared minus 3x minus y. Rearranging that to put it into standard form, I'm going to add my y to both sides and subtract my 179. And that'll leave us with the equation of y equals x squared, oops, sorry, that's a plus there, folks, plus 3x minus 179. So this equation represents then the walking area left in the room. So now we need to create our equation regarding the difference between the perimeter of the room and the perimeter of the tabletop. So as we take a look at that, we got to remember that the perimeter is 2 times greater than the perimeter of the tabletop. So as we put together our lengths, and it's 2 times the tabletop this time. Now let's go ahead and simplify here. So we get 2x plus 2x plus 6 equals 2y. So 4x plus 6 equals 2y. to get y by itself using our inverse operations. And that's going to leave us with y equals 2x plus 3. We now have both of our equations to represent the situation. So our systems of equations is y equals x squared plus 3x minus 179, and y equals 2x plus 3. Now use these two equations to come up with any possible viable solutions, and remember how to find those solutions when looking at a graph. Feel free to use Desmos.